Okay, we want to talk about average rate of change, fundamental triangle, and slope. So, say we got a graph here. We got x-axis, and we got some curve. Kind of looks maybe like a little bit of the cubing function curve. Okay, we want to find the average rate of change on some interval of the x-axis. So, I'm just going to create an interval of the x-axis. And let's just say this is x equals, we can pick a number. If we have people in class, I tell them to, pick a number, show me fingers in one hand to pick a number, then show me fingers in two hands to pick another. Let's just say we got x equals 3 and x equals 7. Then between this point and this point, the x equals 3 point and the x equals 7 point. Now, if this function is y equals f of x, this point would have coordinates 3 f of 3. This point would have coordinates 7 f of 7. Now let's just estimate what the y coordinates might be. Let's say that this line is y equals 12, and this line is y equals 15. So now this point is 3, 12. And it follows then, if that's correct, that f of 3 is 12. This point is 7 f of 7, which equals 7, 15. And incidentally, you'll notice then that f of 7 is 15. Now, the point isn't function notation. The point of this is slope, average rate of change, and so forth. Okay, now, from this point to this point, how much does x change? Well, clearly, x changes from 3 to 7. If you got $3 and later you got $7, that means you gained $4, okay? So your change would be plus $4, and that's plus 4 there, okay? So we subtract where we start from where we end, and that tells us what our change is. And the change in y, well, it changes from 12 to 15. Y changes by 15 minus 12 equals 3. So the change in x is 4. The change in y is 3. And as we know, then we can say, okay, well, delta x then equals 4 when delta y equals 3. Or more properly, delta y is 3 when delta x is 4, at least between these 2 points. Now we can represent, so, okay, well then, as we all know, I think the average rate of change of y with respect to x, and we used to ROC as abbreviation for rate of change, WRT, with respect to so there's your definition of average rate of change. If average rate equals delta y over delta x, in this case, applying that definition, delta y is 3, delta x is 4. So this average rate would be 3, 4. Now, we also say this occurs on the x interval between 3 and 7. So I can put a little qualifier up here. On the interval 3, 7. The closed brackets, well, the square brackets. It's a notation you should be familiar with from your work in open math, okay? And from the text that we've used in class. All right. It's the average rate of change. Okay, now I'm going to construct a fundamental triangle. Fundamental triangle for these 2 points. And that'd be the fundamental triangle for f of x on the interval from 3 to 7 on this interval. First sketch, straight line. Oh man, I missed it by a mile. Close a little bit. Okay. Here's a straight line. That's the hypotenuse of the triangle. And the legs of the triangle, one leg is parallel to the x-axis, it's horizontal. The other is parallel to the y-axis, it's vertical. Okay. Now we draw 2 paths to take us from this point to this point. Okay. Indicate path here to here, and then from here to here by putting a little arrowhead somewhere on the line segment. There we have it. And then another path that takes us from this point to this point is just straight along the hypotenuse. Now we say this horizontal, well, we say the vertical movement is what we call the rise. Okay? Because we're going upward, going in the vertical direction. And I didn't leave myself room to label everything, so I'm going to take just a minute and change these labels. I'll pause the video for a minute so you don't have to watch me do that. Okay, I still got this information. 7f of 7 is 7/15, so f of 7 equals 15. I've written it up here to leave myself some room down here. Also, so I'm not crowding this much. Okay, now the rise y equals 12, y equals 15 is 15 minus 12 equals 3. So there's the rise. The run is from x equals 3 to x equals 7. I'm not going to write out all the words there. I'm just going to say, well, then if we subtract 3 from 7, that tells us how far we went and in what direction. So we take where we end up minus where we start. Now I'm using these arrows. We're starting here, we're ending up here. Where we end up is at x equals 7. Where we start is at x equals 3. So the run is 7 minus 3 equals 4. Now, what I'm constructing here is what I call a fundamental triangle. And the fundamental triangle is always labeled like this. Okay. You wouldn't have to write rise from y equals 12 to y equals 15 is. You just say rise equals 15 minus 12 equals 3, just kind of the same way we set it for the run. Well, it doesn't hurt you to write this out to reinforce what really is going on here. Okay, the run is 7 minus 3, which is 4. So the slope is what? Now, I don't know if in your prerequisite courses, people just gave you a formula for the slope and said use the formula without telling you what it means. But what it means is rise divided by run. Okay. And I think I find that not everybody's familiar with that terminology, which is pretty universal. Okay. So you really want to understand that terminology, but slope is rise over run. Okay. So the slope is rise over run. Well, that's 3/4. So I kind of write that out here away, but now I want to get all the information right here, right on the triangle. So sometimes you'd have to write this a little further away, but the one thing you put on this triangle now is you put that slope, which is 3/4, and you put a rectangular box around it, right on the hypotenuse, right next to the hypotenuse, just like the rise is labeled right next to the rise, the run is labeled right next to the run. This is what I mean by a completely labeled fundamental triangle. And if I ask you to do a completely labeled fundamental triangle, I want to see that. Okay, I won't give you full credit if you don't do that. And these calculations, can be elsewhere. Okay, well, one thing we notice is that the slope is 3/4, and the average rate of change of y with respect to x is 3/4. Well, that's because the change in y is the rise, okay? And the change in x is same as the run. So there's a complete correspondence between the average rate of change and the slope. The reason I kind of emphasize this average rate of change thing on the exam as well is because it's the most fundamental concept you're going to have in your calculus course. Okay. If you're in pre-calculus, presumably you have a calculus course in your future. Not everybody does, but if you do, and most people do, you really want to understand rate of change, because that's what the whole first semester of calculus is built on. That and a couple of other things, but that's a primary thing. And you don't want to lose track of the fact that this derivative thing that you learn to do in calculus is a rate of change. It's actually an instantaneous rate of change. And you learn what we mean by an instantaneous rate of change in calculus. Okay. Well, that's the average rate of change, fundamental triangle and slope. And you really, really make sure you know that and can apply it.